Welcome to this session about deploying modular applications with Apache ACE. I'll start by briefly introducing myself. My name is Marcel Offermans. I am a fellow at Luminous Technologies, a Dutch company, and also a member of the Apache Software Foundation, so heavily involved in open source development as well. That's my Twitter handle. That's the best I could get. And let me quickly also introduce Apache ACE. It's a top-level project at Apache since December 2011. It's basically a software distribution framework for OSGi. And, well, we're going to be talking about it for the next hour or so. We currently have a quite active community, 11 committers, and the URL at the slide gives you more information about the project. So let's start with the agenda. I'm first going to talk a little bit more about modularity in general, explaining why it's important to have it and why you should use it, how you should use it in Java. So a little bit about OSGi there, not too much. Then I'm going to be talking about deployment and deployment complexity, because with modularity comes a lot of complexity at deployment time. So I'm going to be explaining how to deal with that, and that's of course where Apache ACE comes in. So that's what I'll be talking about most of the time. Then I'll discuss a little bit about the different target systems that you can use. Obviously OSGi containers, but there's some other stuff as well. And finally we'll move all of that into the cloud. I'll explain how to do that with ACE, how to configure that, etc. And talk a little bit about future direction, stuff that we're still working on, that we're trying to figure out and get implemented. So, starting with modularity. Modularity itself is nothing new. We've seen it in IT, we've seen it in other disciplines. It is a good way to build more complex systems out of smaller, more manageable building blocks. And in fact, in IT it's nothing new. We've been doing modularity, at least in the designs, for a long time already. If you look at the average architecture document, this will always feature some kind of layering, and within these layers you'll have different modules with different responsibilities. But for a long time, that's also where modularity ended in Java, because when you started implementing your application, you would throw everything together on this great big class path, and it would all be one big bowl of classes that could interact in all kinds of ways that weren't really specified in the architecture document. So modularity is great, but it's probably also a good idea to try and enforce it a little bit more at runtime. And that's where OSGi comes in, and I'll explain a little bit about that later. So, why do modularity? Well, one of the big advantages of building a system in a modular way is that it makes your whole application more maintainable. You can work on individual modules, evolve them over time, update them without actually having to worry about all the other parts of the system. Your modules should be fairly self-contained, might have some APIs to the outside world, but those are always well defined, so it's relatively easy to evolve a module, maybe to re-implement it completely if there's some new technology coming up. So that's where modularity gives you a lot of benefits in terms of maintaining an application. And I guess most of you have experienced this, that after time, if you don't design your application well enough, it becomes harder and harder to change things, up to the point where you maybe even consider to just rewrite the whole thing, because everything you change makes the application fall over, or it becomes so difficult to do that you rather not do it. And that's really a bad reason for redesigning or starting from scratch. You should never reach that point, ideally. Another reason for being modular is adapting to change. And especially again on these longer running projects, there's always going to be changes. At least in the Netherlands, customers don't always know up front exactly what they want. They might do, and they might give you a list of features and requirements, but those are going to change. And that's logical because the world around us changes, so these requirements will evolve over time as well. And therefore, we need to deal with those changes. And again, modularity helps you deal with that. You can more easily replace one or a couple of modules in case your requirements completely change, and there's less risk of having to start over in such scenarios. So that's great as well. And another often mentioned advantage of modularity is what I call the quest for reuse. And going back in time a little bit, reuse has been around for, well, I guess ever since somebody invented the clipboard to start copy-pasting stuff. And as you can see from the picture, you can do a lot of nice things from just copying and pasting stuff and reassembling things in some new and interesting ways. But there's some obvious downsides here. With creating the copies, you're creating a maintenance nightmare because every bug fix you make to one copy doesn't automatically propagate to the other copies. And it gets worse if you start changing those copies a little bit as well. So that might not be ideal. Also, usually in this scenario, you don't have clean APIs. So you're just copying a piece of code and reusing it in a context that maybe it wasn't designed for at all. So quite some time ago, we invented objects. And object-oriented was going to be the answer to all problems we had concerning reuse. Because now we had these nice objects, they have an API, they have an implementation that you can hide from the outside world. So surely, once we all started programming in an object-oriented way, things would be great and we would have reuse of a lot of components. Well, that didn't really happen. Objects have been around for maybe 30 years now or something, and it's not always easy to reuse them. Partly that's because an object never exists by itself. You might have a whole hierarchy of inheritance, so you cannot just copy one class. You have to copy the whole hierarchy. Even if you have this sign on your wall in the company that says inheritance is evil, you should use composition instead. You still need all those composites to make a class work outside of its original context. Plus, maybe a class is also a little bit too small as a unit of resource. Maybe you want something a little bit bigger than that. And that's where more component or module-based systems come in. And I'm a big car fan, so I always use the example of the Formula One, where they have perfected this modular approach. They can replace parts of a Formula One car pretty quickly. They have nice and convenient interfaces, and they can work on these individual components and keep updating them and improving them, and then sticking them on the car and see if they work. And these are typically a little bit bigger compared to just the parts that you saw in the previous photo, which was just a gearbox with lots of axles and stuff. So if we want to use these kinds of components or modules in Java, at the moment the best and sort of de facto standard framework to use is OSGi. And I'm going to explain OSGi really quickly. I'm just going to ask who's already familiar with OSGi before. Almost everybody. I'll do this fairly quickly. So OSGi is a way to create modules in Java. And in Java, we already have a way to package stuff together, which is the jar file. And in a jar file, we can stick different files, classes, other artifacts. And a jar file always has a manifest. And this manifest is used by OSGi to put some extra metadata in and to define what this module is all about. So that starts with a symbolic name and version to identify the module. And next in this example is a bundle class path, because in OSGi, each module or each bundle is completely isolated from the outside world. So it also has its own class path. And here you see we simply include everything that's directly stored in the jar file. And we have this one jar that's embedded inside the jar. That's also on the class path. Next up is the bundle activator. And that's sort of the main method for OSGi. A bundle activator has a start and a stop method. And those are the entry points that get invoked when your bundle gets started and gets stopped. You get a reference to the bundle context, which is sort of your API with the OSGi framework, so you can talk to it. And here is where you can do your stuff. And you also just define the bundle activator in the manifest. OSGi will instantiate it and invoke these methods. Like I said, if you don't do anything, all the classes inside this jar file stay inside the jar. Which is not always convenient, because there are definitely some things you want to share with the outside world. For example, a service interface that you might implement. So what you can do is state in the manifest which packages you want to export. And so you can only export at the package level, not the individual class. So you need to take into account that restriction when designing your code, but usually that's not a big issue. And you can, as you can see, I'm not sure if everybody can see it in the back, but you can also assign a version to a package. And that's important because OSGi supports versioning, supports updating, and can even run 2 different versions of a package side by side. So exporting a package means that it becomes available for other bundles to use. And I've drawn that below in the slide. There's some kind of shared space where all these packages live, and a resolver that tries to hook up these packages in case other bundles need it. Because that's the other side. You can not only export something, you can also import it. And that adds packages to basically the class path of this bundle. They become visible. Somebody else needs to export that package, obviously. If there's nobody else that can do that, the OSGi runtime will give you an error message and your bundle will not start. So you get information about that. But normally the resolver will just silently hook you up with somebody exporting the right version of this package, and you can just start using it that way. So that's OSGi at the sort of class loader level. And then there's one mechanism on top, which is the service registry. And that's really the mechanism for bundles to communicate with each other. So they can share an interface, and they can publish a service in the service registry, and other bundles can look up that service and start invoking methods on it. And in OSGi, invoking methods on services is really quick. It's not like there's some marshalling going on behind the scenes or anything. They're basically just plain Java method calls. So you don't have to worry about performance limitations or anything. And it's okay to have lots of services in your OSGi container. One final big advantage of OSGi is that all these bundles that are running side by side can be updated, installed, uninstalled without affecting the rest of the bundles. So you get a dynamic environment in where you can run and update bundles without stopping the whole world, basically. So that's OSGi in a nutshell. On to the problem that sort of evolves from modular design, and that's taming all the complexity that comes with deployment. And just to define what I mean by deployment, well, we can have many different modules, many different artifacts, and usually you stick them in some kind of repository. And then there's lots of different ways you can combine these artifacts into applications and assign them to different targets. And If you only have a couple of artifacts and a couple of targets, that's probably still doable by hand. Once you get hundreds of artifacts and hundreds of targets, you probably don't want to maintain that by hand anymore. So to sort of resolve that problem of mapping all these artifacts onto different targets, and to also do that over time, because what is defined today might change tomorrow. So you also want to be able to evolve that and remember over time how this mapping was. So you can always look back at the history of a target and see, okay, this was first installed and then that, etc. And keeping track of all of that is basically what Apache ACE does for you. So it helps you make this problem more manageable by automating it. So why would you want to do it? Well, you want to automate it because it's not longer doable by hand. It also gives you, at runtime, a lot of insight into who uses what. So if a customer calls and has a problem, you can instantly see, okay, he has these targets and these artifacts are actually running now on these targets. So that might give you a clue as to what's going on with his system. The history also helps. You can always look back over time. What has changed? Were there perhaps any changes that broke something, etc.? So that's always interesting to be able to see that. And also not unimportant, by automating this and consistently automating it during development, during testing, and during production, you get a single way of deploying everything from your IDE, basically, or from your continuous integration server, all the way up to production. So you don't introduce new possible ways of malfunctioning just because you're using a different mechanism during development than during production. And once you have such a system in place, it's also interesting because it opens up the door for a couple of possible extensions. And I'll get into those a little bit later. I first want to start with just a generic topology. And this shouldn't be taken too literal. There's many different ways you can deploy ACE, but this is just a generic picture where in the center you have a provisioning server. That's sort of the heart of the system. That's where all this mapping between artifacts and targets resides. We have a component repository, which we externalized because a lot of people might already have such a repository. Might be a Maven repository, it might be an OSGi bundle repository or something like that. So we want to be able to use those. On the right, we have all kinds of different targets. And targets talk to the server through a management agent. A management agent is also just an OSGi bundle, and it is responsible for talking to the server, checking if there are updates for the system, and actually deploying those updates. And all the way on the left, we have a client, which nowadays is usually just a web browser. And you can use that to interact with the server, to configure everything, etc. So zooming in a little bit more on this provisioning server, there are three major subsystems: dependency management, deployment, and feedback. I'll go over each of them in order. And we'll start with dependency management. And what's that? That's basically two things. One, a way to organize all these different artifacts that we have. And typically, a larger OSGi application might consist of hundreds of artifacts, so you really get a lot of them. And just looking at a list of them doesn't really tell you that much anymore. So we need some kind of mechanism to group that. And the second issue is then how to map these onto the targets. And for organizing artifacts, we have a system for grouping them. There are actually two levels of grouping. Artifacts are grouped first into features, and features again into distributions. And I always make the analogy of IKEA here, because IKEA makes modular furniture, and they don't sell the individual bolts and planks and stuff, but they configure them into chairs and cupboards and stuff. and give them nice names so customers can order a IFA or a PAX cupboard or something like that. And that's what we're trying to do here as well. Because these individual artifacts, they're so technical. If you're not a developer, you probably don't know what to do with them. But once you start grouping them into functional building blocks, the whole thing becomes way more manageable. So that's basically what we're trying to do when doing dependency management here in OSGi. And we actually store that data into a store repository. And there you have the mapping between artifacts, features, and distributions. Then the next step, mapping them onto the targets. So now we have distributions which can consist of many different artifacts, and we somehow need to map them onto targets. Why did we split this off from the previous slide? Because you could also say, why not stick it in there with the rest? And that's because a lot of the time, this data might already be available in an external system. You might have some kind of CRM system which already tells you, okay, this customer bought these different versions of the product or something like that. So we decided to keep that in a separate repository as well, so you can more easily replace it if you need to. And here we keep the mapping of distributions and targets. And again, this is a many-to-many mapping, so you can install multiple distributions on a single target and vice versa. And to manage all that, I already explained we have a web interface. And I always make a disclaimer that this one was designed by developers, so it's not really nice to look at. We can probably do a better job on this. And at the same time, we've had many discussions with people about what kind of user interface do they want on top of ACE. And everybody wants something different. So it's kind of hard for us to make one interface that everybody's happy with. So what we did, we added a REST API as well. So you can programmatically talk to it. And we even have a Java API in case you want to talk directly from OSGi components to this server. So that way you can make your own user interface if you think you need something else. So that concludes dependency management. Next up is deployment. And deployment is really all about getting the right artifacts to the right targets. It basically gets its information from everything we did in the dependency management section. It just sort of organizes this information in a different way, a way that is really suited to creating a scalable system that allows you to quickly distribute to many different targets at the same time. Server side, it consists of a deployment repository, and on the target we have the management agent which actually initiates the communication with this server part. And the deployment repository basically only keeps a mapping now between targets and artifacts. So all the features and distributions that we had to make this more comprehensible for humans, we throw them away again because machines can handle big numbers of artifacts. They don't need the levels in between. And just create a straight mapping from that. And that actually gives you a repository that looks somewhat like this. We have different targets in there, in this example too. And for each target, we keep different versions of the software. So every time in the dependency management section you change something, ACE will calculate for you, okay, what does this change mean? Which targets actually are affected by this change? So which targets need to be updated? And that means that, well, not every change will affect all targets. So you will get different versions of each target. Every time something changes, a new version for that target will be created. A list of artifacts will be made that belong to this version, and that's what will be stored in this repository. And, well, as you can guess, the management agent on the other side communicates with this repository. And we can break the management agent down in a couple of individual parts. There's a scheduler in there. We have a cache for caching all the versions so we can more quickly roll back to all the versions. Don't need to go over the network. There's an audit log. I will talk about that a little bit later. And we've abstracted away some mechanisms that most people will want to change, such as, for example, identification, which is a simple API that determines how to generate a unique identification for a target system. And depending on what that target system is, if it's some kind of server or maybe an embedded device, you might have a different way of creating that unique identification. It might be a MAC address of a network interface or something in the device or whatever. So this management agent uses a concept called deployment packages, and they're actually part of an OSGi standard called deployment admin. And deployment packages are basically a way to package up all the changes or all the artifacts that you need to install a version of the software on a target and create one big jar file out of them. And this jar file will either contain everything, or in case of a fix or delta package, you can also send a jar file that's just the delta between two different versions. So you don't have to send everything every time. A nice feature is that any installations or updates are transactional. So if somewhere during the installation of your bundle something goes wrong, it will automatically roll back all the changes it did and get you back to the last known working version, which, well, with hundreds of different bundles can be rather difficult to do if you have to do all of that by hand. And probably you don't want to end up with half a new version as well. So that's a good feature to have. We can sign these packages to make them more secure, make sure nobody's tampered with them, which in a lot of environments is also very interesting. And maybe the coolest feature is that we can create resource processors. And resource processors allow us to work with new types of artifacts and install them on a target, artifacts that we previously didn't think about. And there you can think about maybe a database schema for a database that you're using on this target system, or maybe a Debian package that you want to install on the operating system that this target is running on. And a resource processor is just a Java bundle. It is some code that will be shipped along with this artifact, and you can use this code to, on the target, install this artifact. So it might talk to the database and make all the schema changes for you. And all of this, again, happens in this transaction. So if something along the way goes wrong, you can roll everything back and go back to the previous version. Of course, you have to write your database code in such a way that you can actually do that. So not only should it make schema changes, it should also be able to roll them back again. But, well, that's then your problem to solve. But at least you have a mechanism for making that work. And the OSGi spec actually has a example of a resource processor called autoconfig, which is used to ship configuration data, which is something almost every application needs. So that's good to have. So that sort of concludes the first two parts of the server. And there's three repositories involved, the store, the license, and the deployment repository. And basically, if you make a change to either the store or license repository, that has implications on the deployment repository. So ACE will sort of calculate that for you and create a new version of that deployment repository. That leaves us with one last bit, and that's feedback. And arguably, that's maybe the most important one, because feedback allows you to, well, as the name says, get feedback about what happens on a target. Because it's nice to ship all kinds of new software and other artifacts to it, but if you're not sure that this actually works, then the system is not really that useful. So what we've done there is, on the actual target, we keep what we call an audit log, which is a log file that records every lifecycle change that occurs on a target. So obviously, this is every time something gets added or gets updated through the management agent. But we also log stuff like, okay, now the user has switched off the system, now it's coming back on. So all those changes are recorded as well. And not only do we record them, we also send them back to the server so we can process them offline, because targets will not always be on 24/7, depending on what type of device they are. And most certainly they will not always be reachable from whatever machine you're using to monitor them. Hopefully they can contact the provisioning server, but most of the time not the other way around. So keeping these logs on the server allows us to do all kinds of interesting processing. And in fact, we've already seen a lot of people who said, well, this is such a useful feature. Can I add my own application logging to this as well? So I can get some application logs on my server and analyze them there. So we already built this system in a way that you can easily extend it and add your own logs as well. So that's ACE, the server part, in a nutshell. Now I promised to also talk a little bit about the different targets, the different containers that we can deploy to. And the most obvious ones are actually just plain OSGi implementations. There's 3 major open source ones. Apache Felix, I'm a committer, so I'm placing that at the top. And there's Eclipse Equinox. Eclipse has started to use OSGi ever since version 3 was released. Before that, they had their own proprietary plugin mechanism, but that's ancient history by now. And there's a third one that's called Knopflerfish, or however you pronounce that. That's always a little bit trickier. There's lots of other ones out there. These are the 3 major open source ones. There's commercial ones as well, and there's smaller open source versions also. So naturally, these frameworks are good targets for ACE. And the OSGi specification really is good enough that it doesn't matter which framework you choose. Your code runs on any of them. What's also interesting is that you can deploy directly to application servers. And I'm naming Glassfish as an example here because there are already other application servers such as JBoss, and well, all major ones are starting to support OSGi, are in various stages of that. But Glassfish is a good example because they really started from scratch. They started on top of Apache Felix, and they built the whole application server as a set of modules on top of OSGi. That's interesting because that no doubt sped up the development of Glassfish itself. It's also interesting because maybe you can then just deploy the parts of Glassfish that you really need for your application. Maybe it's not really Java EE compatible then anymore because then it needs certain things to always be available, but that might not be that important for you. And maybe the other more interesting part is it also allows you to directly deploy OSGi modules into the application server so you can build your own applications in a modular way. And just like with the plain OSGi containers, all we really need to do is just get this management agent, stick it into Glassfish, and configure it so it can talk to the ACE server. And we can use that to actually get new code onto the application server. Out of the box, we even provide some code that helps you with that. So we have a component that can easily launch a version of Glassfish, get the management agent inside, and help you set up that system. Due to some licensing restrictions, Glassfish has an incompatible license with some Apache stuff. We cannot actually ship it with a copy of Glassfish, so you have to sort of get the zip file yourself and put it next to the code we have, but then it will work. So that's really interesting and a good way for future enterprise applications to become more modular and to make deployments easier. Another option, and this is way out there on a Java conference, so I won't talk about it for too long, but there's also an Apache project called celix, which basically is a modular runtime for C code. And while there's less and less C code being used, in some areas there's still some legacy C code available, and you might also want to modularize that, and you might also want to be able to update that in a more dynamic way. So celix makes this more modular, and also sort of interoperates with Apache ACE and supports actually these deployment packages. So with ACE, you can also ship C bundles or modules onto a system and update it in that way. Obviously, a C runtime probably isn't as dynamic as a Java one, so you probably end up having to restart the application after a change that you make. Depends a little bit on the change. Some stuff they can add on the fly, such as new DLLs, but some stuff is harder to do in a dynamic way, but they go a long way. And another one, maybe also a little bit outside of the scope here, is deploying on Android. And just as a quick overview, Android uses Java the language. I'm probably already in trouble for saying that, but it does seem to work. And they run on a different virtual machine called Dalvik, which has slightly different bytecode. And actually, in Android, you have many different instances of that virtual machine, one for each application. On the other hand, OSGi allows you to run different applications side by side in the same virtual machine. Well, each has its advantages. OSGi has an advantage that if you get communication between applications, due to the fact that they're all in the same virtual machine, that communication is going to be very quick. It's just method calls. You also get more reuse. If you have libraries that are shared by multiple applications, they're running in the same virtual machine again, so you can easily reuse that and don't have to have multiple copies lying around. On the other hand, Dalvik has the great advantage that if one application crashes, it doesn't bring the whole virtual machine down because there's a single virtual machine for every application. So, as with a lot of things in life, there's different trade-offs here. So you might end up with a combination of the two. It's definitely interesting that if you develop all your applications in a modular way, that even for Android, you can deploy all these modules together as a single application on such a platform. So, after a very long introduction, that finally brings us to the cloud aspect of this talk. And let's take a look at what we need to do to actually run all this stuff in the cloud. And first I want to go back to the topology slide that I showed earlier. And apart from adding the clouds that everybody has on their cloud slides, there's one extra part, which is the node manager. We can just run ACE in the cloud. That's not any different from running it on a local system. We can get the component repository in the cloud. And then the next step is, okay, now I actually want to run targets in the cloud. So we need to do something extra to be able to bootstrap those new targets and actually run them. And that's what we call the node manager. And zooming into that for a little while. The node manager is a component that is responsible for bootstrapping the actual node. So the compute node that runs in the cloud. It will bootstrap Java. It will bootstrap the OSGi framework, install a management agent, and actually launch that. And then this management agent will be configured already to go back to ACE to get the artifacts that you configured for it, and those will be shipped to the system. And typically on Amazon, we can start a node from scratch in about 2 minutes or so. So that's fairly okay. Another thing the node manager does is it measures all kinds of performance data. And I'll get back to that in a slide or two, but that allows us to monitor how busy a node is and maybe do something if it becomes too busy. So ACE configure is out of the box already configured to be used in a cloud. Under the covers, we actually use a very popular library called jclouds, which is kind of an abstraction layer. And what we did is we used that and we implemented that for now for Amazon. It's quite easy using jclouds to add support for other clouds as well. That's just something we haven't gotten to yet. And what you need to do in ACE is there's a sample configuration file. You need to fill that out and add some real values to that. And once you've done that, you can simply deploy ACE in a cloud and start working with it. So what do you need to do? You need to tell it where the ACE server can actually be reached. So that's a URL of where you actually installed ACE. It can be in the cloud. It doesn't have to be. You can run ACE outside of the cloud and still have nodes running in the cloud. At Amazon, you need to tell Amazon what machine ID you want to use and what location. So you can configure that here as well. And most important, something hooked up to your credit card. You need to enter your access key and password. So you can talk to the Amazon APIs and actually start new nodes. Then we have a tag prefix, which is just a convenience feature, because in the Amazon Web Console, you see a name for every node that gets created. And if you use that same Amazon account for other things than just starting nodes with ACE, you can use this prefix. It will be stuck in front of every node that ACE makes, so you can easily identify those nodes. And then we have a couple of things that configure and run the whole bootstrapping mechanism. In this case, we have a machine image that didn't include an Oracle JVM by default, so we have a tiny script that will fetch that and install it. We've opened up a few extra ports because by default all the ports are closed, so you can open up a few extra ones if you need communication from the outside. And you can configure things as run this as root or not, and even fetch some extra files if you need them during the bootstrap process. So that's all you need to do, and then you're ready to run ACE in the cloud. And how does that actually work? You go to the web interface, and the web interface contains a column where you can see the different targets that you have configured. And here you can just create a new target, double click on it, and you'll get a dialog that looks a little bit like this. I think we already updated it. It's a little bit old screenshot, but it shows the basics. It shows you that you can simply hit the start button, and that will actually start a communication with Amazon, start up a node, do the whole bootstrap process, and get this node up and running. So that's basically all you need to do. Just create a new target, hit start, wait for maybe 2 minutes, and your node is up and running. So that's really easy and cool to do. Then I already told you there's something else running as part of this node manager, and that's a monitoring framework. And that's actually extensible, so you can add your own probes to it. And just for a demo, we added some simple ones, such as CPU usage, disk usage, network traffic, and memory usage. And all the information that's aggregated by these probes is sent again back to the server. So it can be analyzed there, and we actually have some simple graphing options here. You can see, I think, 9 seconds of network traffic. So it's not really that interesting, but you can plot for longer periods as well. And this is important because this is usually information that you can use if you want to do your own accounting based on how much of an application your customers are using. You might use it as the basis for a clustering solution, detecting that a node gets very busy and maybe creating another node and stick a load balancer in front of that. So that's really what the monitoring part of ACE is for. And finally, just to show you a little bit about how we do cloud support under the covers, we have a monitoring or a node launcher API. And this really is the API that you need to implement if you want to add support for a different type of cloud, or maybe your own private cloud or whatever. It's fairly simple. You need to be able to start and stop nodes. You can create a default configuration, which is some kind of node launcher configuration interface. There you can add your cloud-specific settings. And if you've done that, you can just start and stop nodes. So this shouldn't be too hard to implement for your own cloud. And especially if you use JClouds to implement all of this, it's not that hard to do. So that's really how we can run ACE in the cloud. And I want to finish off with some future directions and just to give you an idea of what we're working on right now. And probably the biggest one at the moment is support for dynamic clustering. And that can mean many things, and we're working on many things in that area. On the one hand, for example, OSGi has a specification called remote services that allows you to distribute applications over multiple nodes, get sort of a federated service registry, and do remote invocations. So that's one part of this solution. We're currently also working on supporting different load balancers, so we can stick a load balancer in front of an application, have that communicate with some kind of cluster manager, and send requests to different nodes that are running behind that, and make all of that in such a way that it's really dynamic, that we can, when load is high, add extra nodes, and when it's low again, scale back. And actually in a session tomorrow, and I'll add a short plug to that in a few minutes, we have a real-world use case of how we use that already today. So it's not all future, but it's definitely not done yet. So it's something we're working on at the moment and trying to improve. Two other things we want to do is to integrate better with, on the one hand, a project called Amdatu. This is an open source project that is focused on creating modular components for cloud applications. So it contains a lot of components that you use in typical cloud applications. Naturally, it supports Apache ACE already, but we want to integrate with that a little bit more. It also allows you to use all kinds of NoSQL solutions and run them in OSGi, add REST APIs in a really convenient and easy way. We have enterprise search solutions, and there's lots of components that we're working on and making sure that we have a comprehensive stack for building cloud applications. And the other project is B&D tools. This is something completely different. This is actually an IDE plugin to make working with OSGi a lot easier. This is currently available for Eclipse only. So one of the things we're hoping is that somebody ports this environment to other IDEs as well. And what we're trying to do is integrate with this development environment so that from your IDE, you can directly deploy stuff onto cloud nodes just by hitting save and having ACE in the background, pick up all the artifacts that you created, uploading them to the provisioning server, and then maybe spreading them out to the different nodes. Obviously, that wouldn't be production nodes, but for quick testing, it would be very convenient if you could publish such changes to your testing servers or maybe your development servers even, without having to do extra steps yourself. So that's still some work to be done there. We have all the REST APIs in place to make that work, but yeah, there's still stuff left to do. And as promised, there's a nice session tomorrow, which I will be giving together with my colleague Paul Bakker. This is a real-world use case about using OSGi in a cloud environment, and we've actually used it to build a system for Dutch schools that creates a personalized learning environment. So that's a really cool project, and it shows off some of the stuff we can already do with dynamic clustering, etc. And that's all based on Apache ACE and the Amdatu project. So if you want to know more from real-world use cases, from the trenches, so to speak, visit that session. Okay, that's actually it for me. So I think I have a couple of minutes left for questions. So, yeah.
You mentioned Node Launcher in the context of cloud. Can it work outside of that? Can
Yeah.
you SSH into machines and do the same kind of thing?
Yeah, you can do that as well. Yeah, so that would be your other option. Use SSH, or in OSGi we also have a thing called the web console, which is a web-based way to create interaction with the OSGi framework and really look at individual bundles and start and stop them through a web API. Whether you want to expose all of that to your customers, that's up to you, but that's definitely also a way to do it. Yeah. Yeah, in the back.
In a lot of organizations, mine included, there is a separation between operational staff and development staff, and the development staff is not supposed to be deployed into production. So is that sort of demarcation of responsibility reflected within ACE?
Yes, it's something I didn't show, but actually when you use the web interface of ACE, you need to log into it, and you can have different roles. And based on your role, there's stuff you can and cannot do. So that's one part of the solution we have for that. And also in a lot of organizations, you see that you have different provisioning servers for development and for production. And we also have ways to sort of promote artifacts from one environment to the other. So that way you don't get in each other's ways. They're completely isolated if you want that, and you're just transferring stuff to production in a very controlled way. So that's up to you. There's different ways to set that up. Yeah. Lots of different, well, sorry, yeah.
On the future slides, I was hoping to see that there'd be some kind of convergence with Carafe and its feature concept. Is that something that will just continue to coexist, or what's the...
I don't know if it will coexist. It's definitely something we want to interoperate with, because the Carafe features already define groupings of artifacts, just like we can do in ACE. So our first version of support hopefully will be to be able to read these Carafe features and directly use them in ACE. That's one thing. And I think from there's many other interesting stuff we could do. Actually, I filed a bug report in Carafe a long time ago because Carafe features don't support the mechanism of being updated right now. And that's something we really need for ACE to work. Carafe can just uninstall and reinstall new stuff. And there's a technical difference in OSGi compared to just updating a bundle. So there's some work to figure out there, but we're definitely talking to that community as well, trying to make them work together. Yeah. Yeah.
I was wondering if there was already an out-of-the-box integration with continuous integration platforms like Jenkins, that they can provide the set of features and set of distributions.
That's not yet available, a sort of a standard integration bundle for Jenkins, for stuff like Bamboo, for other integration servers. We have the REST API, so creating a sort of a small script for that would be fairly straightforward, but we haven't included that yet in ACE. Would be a nice contribution to have that, yeah. So if you want to help us out with that, please do. Yeah.
Just another question, so stuff like, what I've seen is now like the jar file, the bundles are like provisioned.
Mm-hmm.
Is there already out of the box way to provision config files, like config properties?
Yeah. That was actually one of the resource processors that I briefly mentioned, was for configuration files. So that's already included in ACE by default. So we can provision bundles and configuration files, and you can extend that mechanism yourself. Yeah. Yep.
How does it work with Echo? It's the split system.
And we currently don't have an integration for Tyco, but in the end, Tyco is also just a development environment to create OSGi applications. So I think based on the REST APIs that we have, writing such an integration would not be that hard. If you're using Tyco and also maybe Nexus as a repository, then you could have used Nexus support for the OSGi bundle repository and use that directly in ACE. But it's also fairly straightforward to sort of promote bundles coming out of Tyco and stick them in the repository for ACE. But it's not done yet. That's another area where we could use some help. Yeah.
I mean, this is just related. You wouldn't necessarily need to connect to Tyco, I would believe, but going via a P2 repository would probably be. Looked into that?
We've looked into that, but haven't done it yet. So that's one of the other repositories we would love to add support for. Yeah, so not done yet, but shouldn't be too hard as well. Yeah.
Curious about scaling. What's the largest implementation base as far as targets that there were?
I think at the moment the current biggest implementation is a couple of thousand of targets, and those are actually embedded devices moving around inside cars, so they are on and offline all the time. We've done experiments to prove that ACE scales way beyond thousands of systems, but that's currently the largest deployment that I know of in the field. I mean, not everybody tells me what they're doing with ACE, but yeah, that's what I know of. Yeah. Okay, then that's it. Thank you.